All right, an inclined plane basic problem. Here we have a surface or a floor. Here we have an inclined plane, a plane that has been inclined. 20-degree angle. We'll pretend. Okay, clearly that's not 20 degrees in the real world, but we'll pretend. Now we have a block on the inclined plane. I will be ignoring the friction and stuff like that for right now. We want to look at decomposing the forces. So here, you might have to get in a different mindset, like perpendicular, parallel, but it's like horizontal and vertical. So before, when we were doing equations of motion, we got horizontal and vertical. And remember, we need to look at the two when we're working problems, because as Galileo and Newton showed, they are that aspect of the motion of things is affected differently. Okay, we can separate for separate analysis the horizontal and vertical. Get something, separate it out, bring it back together. In our thought, in the real world, it's all one. In our thinking, we can analyze and then synthesize. Take it apart, put it together. Analyze, synthesize. So, and the one thing here is that these are perpendicular. When we're doing this, instead of horizontal and vertical, we got like this we can think of as like along the board, which is the parallel to the board. Along the board or whatever, inclined plane, you know. Then vertical would be like our perpendicular. Or we're using the word, we're right, normal. Normal. So this would be parallel to the board, along it in the same direction as the board. Normal, perpendicular to the board. Okay, parallel to the board, normal to the board. In the same direction, perpendicular. So we did two things. We did horizontal versus vertical now. Now we want to do some parallel versus normal. Okay. So they're still like perpendicular to each other. X and Y axis, horizontal and vertical, parallel and normal. Just a different perspective on the same thing. Okay. So we got, if we want to see what gravity is doing to this, as we've demonstrated in class, we get a 2x4. If we hold it, the eraser didn't move, friction's holding it. Eventually we get it at a shallow angle, and so the eraser goes down slowly and speeds up. But if it's at a steeper angle, it goes faster. So parallel to the plane, the board, there's less force from gravity here. When you increase it, there's more force from gravity here. And we know because here, the change in velocity isn't as much. Less change in velocity, less acceleration, less force, because F equals ma. Okay. Less change in velocity in a certain time is less acceleration, means less force. More change in velocity means more acceleration, means more force. Less of this, less of that. More of this, more of that in this context. So, the steeper the angle, the greater the gravitational force along the board. The less the angle, the less. It varies from like none to like all. Okay? This constant variation and how much force there is. So, that's some general ideas. Now, when we get this, we need to see how much gravitational force is along here, and we use our angles. So, gravitational force is acting towards the center of the Earth, perpendicular to the ground, locally, pretty much. So here, gravitational force there, continue this, and bam, it's perpendicular to the ground. A right triangle, just do this part, a right triangle. If that's 20, that's 70, okay? Then we get, remember, the normal force is up, and it's there because gravity's pulling it into the board. You got gravity pulling something into the board and my arm holding it up. Net force is 0. No change in velocity, net force is 0. No change in velocity, no net force. So here, gravity pulling down, board pushing up. There's going to be some of that going on. So gravity's here, but then gravity's pulling it into the board as well. So we got this part, you know, perpendicular to the board. Then we got the normal force balancing it. And so if this is 90, this is 90. 70 minus 90 is 20. Ta-da! And then we can go here. And so here's the force normal to, it's like Fg, normal, you know. Fg equals the normal force in this way. This part of the gravity. So I'm just going to call it that. But remember, the board is pushing the normal force. This is the force of gravity. I'll do a perpendicular. How about that? Then the normal can stay normal. So force of gravity perpendicular, and the force of gravity parallel. Parallel means in the same direction as the board. These are going in the same direction. So this is what's pulling something down the slope. And so notice we got, and we drew this over here, perpendicular. So 20 there, 70, but we need this. Here's our gravitational force. And we get the force of gravity. That's our hypotenuse. And we got 20 opposite. Opposite over hypotenuse. Opposite over hypotenuse. So I can call this as a force of gravity. And then with our trig stuff, we would see that we get the force of gravity and the parallel. We'll do it like this first. Sine of 20 equals opposite over hypotenuse. Thus and therefore and hence, the parallel force is Fg times sine 20. And if we have F perpendicular, that'd be cosine. Adjacent over hypotenuse is cosine. So cosine 20 is F perp over Fg. And this is something we should be able to figure out ourselves because we've already done vectors and trigonometry at this point in this particular class. Not everybody out there watching in viewer land, but some people I know who I'm working with should be able to do this on their own because they should know trig and they should know vectors and there shouldn't be any problem. But we all have things to learn and sometimes things are hidden in plain sight. And I remember when I was younger, I didn't always get things that would seem obvious to me now or to a professor or whatever. We have to learn. All good. That's the way humans are. So there. Put the thing is try to learn to think of some of this yourself. Go into the unknown. Be confident in what you know and bring into play what you know in the past. One thing that unfortunately happens when some people are learning something new is that they get focused on the new and everything they knew before gets like ignored. But it can help, as it did here. We couldn't do this without the stuff we knew before. This would be impossible. We got to remember our trick, and we do. We can use it. So that's what we'll do on this stuff. The force down the slope, if this is the angle we're given, not some other. If we have this, we do force of gravity, sine of the angle. And then force of gravity, cosine of the angle to get parallel. Perpendicular. Perpendicular, force of gravity, cosine, parallel, force of gravity, sine. And remember, we can't, if we want to get it right, we can't just get the angle and use sine and cosine like this, no matter what the angle is. If it's the angle between the ground and the incline, we can do this. If it's some other angle they give you, we need to make sure we're thinking about it correctly. The geometry and the physics is right. Okay, so gravity is pulling down perpendicular to the ground locally towards the center of the earth. And we can decompose it. We go perpendicular to the plane and then parallel to it. And we got this triangle. We can get these numbers from here. Remember this one, if this is 20 and that's 90, that's 70. Since these are perpendicular, they're complementary. 90 minus 70 is 20. And then we can do our trick. So, you know, we got like, and then 20, FG, F perp, F parallel, and then you can see sine of 20 is opposite over hypotenuse, and hence cosine of 20 is adjacent over hypotenuse, and hence, okay? And that is something we'll be using. So that is an important thing to use in inclined plane problems. Enjoy using it.